Hello and welcome to Textbook Engineering Problem. Today we're working on Elementary Principles of Chemical Processes 3rd edition, and we're doing problem number 3.15. It says liquid toluene is flowing through a pipe at a rate of 175 meters cubed per hour. Part A, what is the mass flow rate of this stream in kilograms per minute? Mass equals volumetric flow rate times density, 175 meters cubed per hour, and we need to know the density of toluene, and that is, you can look this up in the back of your book, or you can just Google it, kilograms per meter cubed. And they want it in minutes, kilograms per minute. So in 1 hour there are 60 minutes. Okay, and that equals kilograms per minute. Okay, that's the answer to part A. Part B. What is the molar flow rate in moles per second? Okay, in order to know the molar flow rate, we need to know the molar mass. And that equals 9,213 kilograms per kilomole. Okay, so now we've got our mass flow rate goes to mole flow rate times the molar mass. So we just do our per minute, that's our mass flow rate, and then divided by our molar mass, 82.13 kilograms per kilomole, and then there are 10 kilomole, there are 10 to the 3 moles per kilomole. And they want it in seconds, so in 1 minute there are 60 seconds. Okay. And this equals 456.9 moles per second. Okay. So part C says, in fact, the answer to part A is only an approximation that is almost certain to be slightly in error. What do you have to assume to obtain the answer? Well, let's look back at part A. We assumed that the mass flow rate equals the volumetric flow rate times the density. So this was our assumption. And it's a pretty good assumption. The key factor here being the density. Well, the density is a physical property of the material that you're using. And the physical properties are determined by two thermodynamic parameters: the pressure and the temperature. The pressure is how much pressure or how much you're pushing on the material, and the temperature is like a measurement of how hot something is, how much energy something has. The pressure is, it doesn't have a lot of effect on liquids. So you can push on a liquid, but liquids are generally incompressible. So if you push on the liquid, it doesn't really change the density very much. So you have water in a jar or in a piston or something like that, and you start pushing down on it really hard, the water's not really going to do very much. It's going to have about the same density because the molecules and atoms are still really close together. So there's not a lot of space there to push down on. The temperature, however, you start injecting some energy into that system, the molecules will vibrate a lot more, and some of the bonds will break, they'll have more motion. that has a bigger impact on density than the pressure does. And so a lot of times you'll just see density as a function of temperature, where pressure is kind of left out of the equation. And sometimes that works, sometimes that doesn't. But that's an assumption you make a lot of times in engineering problems. You just assume that the density is only a function of the temperature because it's a very weak function of the pressure. And that being said, that only works for liquids. If we were working with a gas, there's a lot more space in between gaseous molecules. You can put up, filling up a gas cylinder, for instance, you put in a ton of gas, you increase the pressure of that gas tank, the density is going to go way up. And so it's a strong function of pressure in its gaseous state. So you have to be careful about when you make that assumption. Is pressure going to make an impact on your density, or is it not? And then you also have to make sure you have the right temperature, because that will also change your density calculation a lot as well. The assumption we made in part A had to do with what was the density of the toluene, and so we assumed that it was at a certain temperature and that it was not a function of the pressure. Okay, that is it for problem number 3.15. If you have any questions or comments, or you want to start a discussion about how to do this, please leave a comment down below, and I'd be happy to hear from you. Thanks for joining me again, and hope to see you in the next video.